the recording now. All right, and I believe the session is in recording, so I'll go ahead and get started with the slides. So again, hello everyone. I know we had some people jump in a little late. Some people are jumping in just at the moment, but my name is Chris Lopez. I am the Student Success Librarian here at the MCC. And now a few more people are jumping in, yeah, welcome into the final session of the Digital Horizon series workshops. If some of you all had the chance to jump into some of those other workshops, I'm sure you love that content. And for all participants, recordings of the workshops, the slides, and different resources will be shared out. And in fact, before I forget, I do have a resource for our community here. It's basically going, because I know I'm going to forget, it's going to be a link, a document with a lot of the resources I'm going to mention in case it's right for some of you. I know it is the first time you are seeing this, some of this content. So I do want to make sure you know where to find it. Last little piece of housekeeping and introduction. I have a background in information seeking, like surprise, I'm a librarian, but also when I was in LA at UCLA, that we had the Center for Critical Internet Inquiry. And that was a lot of fun, and we focused a lot on machine learning. There was a wonderful professor there. Her name was Dr. Sophia Noble. She wrote a great book called Algorithms of Oppression. And so when a lot of the stuff with generative AI started to blow up, especially as it relates to information seeking, I started focusing a lot more on that, and now in the certification process to better understand natural language processing, machine learning, which is under the hood for a lot of these tools in question. So what we're going to be doing today, hopefully we can run all the way through it. If we go over a little, I apologize. But what I want to do is first, just in general, lay some groundwork for what is AI literacy. Right, I know when we immediately hear literacy, we instantly think of like the ability to read or write. But when we start thinking about literacy in like broader context, or more like in terms of sociology, literacy also has to do with how we read the situation, how we read the context in which we are consuming language, consuming thoughts, and being able to critically understand, okay, where is this coming from? Who's saying it? What are their credentials? What's the context here? And what I want to do is have that same conversation about artificial intelligence. And that's going to move us into 3 different topics. We're going to talk a little bit about why all the hype, because, right, it does kind of feel like there has just been this wave that there hasn't been in quite a while around technology in general, but maybe this technology in particular is better to say. What I also want to get into is what the hype is missing, or what's starting to be shared, but it's kind of in the fine print. For some of you who regularly jump into ChatGPT or Anthropic with Claude, you kind of see those little caveats of what to do, what not to expect. Please, don't trust. It's funny what we see, but we still have to kind of emphasize like what the hype is missing. And then I want to have a general conversation with each other, if everybody's comfortable with it, to talk about what it means to be critical users of AI. So that's where we're going. But first, AI literacy. You can't talk about or build a literacy concept without at least having some definition, right? We have to know what we're talking about so we can recognize it and critically engage it. On the more computer science side of things, there's a very just straightforward explanation or definition, I should say, for what AI is. Artificial intelligence seeks to make computers do the sorts of things that minds can do. And it involves psychological skills such as perception, association, prediction, planning, and motor control. Something that this definition doesn't get into is part of the goal of artificial intelligence is to take these very specific, or these what's called narrow AI tools that do a very specific task, whether it's recognize a face, produce a bit of text, autocomplete, move a car from point A to point B, to general AI, that is artificial intelligence systems that are capable of multiple tasks able to display a range of the different cognitive and psychological or affective forms of intelligence we possess, and the fact that these AI could then do it in newer circumstances and learn how to do it in the newer circumstances. And the fact is we have not reached AGI, or artificial general intelligence, but that's kind of behind what's going on in terms of the goal, the aim here. But I think we need to consider another definition of AI. Kate Crawford, I linked out to her book in the document. She has a broader sociological definition that I think is very important, because often when we think of AI, and even some of my icons like that brain with the various nodes in it, it kind of gives a sense of it's otherworldly, it's immaterial, it's digital. But Dr. Crawford says AI is neither artificial nor intelligent. Rather, artificial intelligence is both embodied and material, made from natural resources, fuel, human labor, infrastructures, logistics, histories, classifications. AI systems both reflect and produce social relations and understandings of the world. And that is a bit of a mouthful. It's like, okay, what? But what Dr. Crawford's getting at is humans are very much in the AI that is created, right? Especially with not being at a point of AGI that's just improving itself. A lot of ourselves shows up in the AI, and we're going to get into this in a little bit. It takes a lot of the earth. It takes a lot of our underpaid labor or our labor in general that we're now even recognized for in the data we produce for these machines. And so all of those things are a piece of what AI is. So including definitions, I think it's really helpful. I remember first recognizing that, because when I saw a lot of the initial machine or artificial intelligence, when I was first studying this, I thought, oh, I guess machine learning is the only thing. And that's quite the opposite is true. Artificial intelligence is a huge field. Right now, as you can even see, machine learning is one of those fields. And it does not only encompass a lot, but it is gaining a lot of attention right now. And it's, like I said, under the hood of a lot of the technologies that are very popular. And so the angst of some of the researchers who are in some of these other fields of AI, they feel like machine learning maybe is getting too much attention for not all the right reasons. And we'll talk a little bit about what machine learning is doing. But essentially, machine learning, to put simply, these are systems or programs designed with a very specific task or objective. And the idea is that you can train these machines, various types of ways to train them, but train them on the data that you want them to work with and perform a task on. And through the training, through further interaction with new data, the system, the machine learning system, begins to learn better and better how to perform those specific things. And we'll talk about one specific form of machine learning, that's deep learning, because that's a part of, again, a lot of the technical space. And that's very important when we're talking about AI literacy, getting a good understanding of what's happening under the hood and what we can honestly say these things are capable of. So we talked a little bit about definition. We talked a little bit about the different fields, what we're talking about. So if I can just go make apologies, there's some construction outside and I get very easily distracted. But if I were to put some words to what is AI literacy, I would say it's the practice of critically engaging artificial intelligence systems by investigating their social origins and their technical origins, identifying their functional limitations, and considering the ethical implications of deploying and using them. And I don't want to make it seem like there's only there's only one answer for these topics, these questions, but certainly having these discussions amongst ourselves, with as ourselves individually, will be the part of practicing AI literacy. And this is also a very individual definition of it. I think there is a form of collective AI literacy that would be fun to kind of explore in another conversation. But again, that was kind of a lot. So what to do, if I could break down AI literacy to the kinds of questions it's helpful to ask. and kind of map it to what we're going to be doing in a little bit, right? We're basically asking who built these systems, what is their purpose, who gets to use them. Did I tell you this definition? That's a great question. I did not have much of AI produce the content that you see here, but that could be fun. We could ask some of the bots to give us a definition of itself if we wanted to. But right, we're asking who built these systems, for what purpose, what do the creators claim they can do, what can they actually do? That's going to get into what the hype misses. And then, of course, what does it cost us to deploy and use these systems? That's going to be a part of our discussion of becoming critical users of AI. So before I pause there, I just wanted to give a little room for any questions or thoughts people may have at this point. And feel free to put it in the chat or drop in, or if we're ready to go, throw up those emojis. Thumbs up, smiley face, party hat, looking. All right, excellent. So the first question is, why the hype? So I got a lot of images here. I put a lot of these images here to kind of reinforce that thing I brought up earlier before, that being there's been a lot of breakthroughs in the field already. So what's going on? What's different, right? We can go all the way back to the 1950s with Frank Rosenblatt, who really created the first object recognition system and was a big proponent of what is deep learning, that specific subfield of machine learning, or what would eventually become that. And then, you know, skip ahead a decade, in 1960s, you have Joseph Weizenbaum's ELIZA. And this ELIZA program was basically almost like a chatbot. And so with that, it was very interesting. You know, people are literally, you know, imagine there's only just one computer that can really jump into ChatGPT, and everybody's around each other watching and just amazed by it. But right, so we have that. But then fast forward even more into our century, right? We had IBM's Watson, who was really great at things like Jeopardy. I think it beat one of the Jeopardy champions. We have Siri. On a sillier note, we have some basic machine learning and some robots like the Roomba vacuums. And of course, we have the pursuit of self-driving cars. We have driver-assisted systems in place, but I wouldn't go so far to say that, you know, self-driving is truly here. But right, all that to say, we have a lot of AI systems already in place. What's the big deal? And so part of the workshop description that I shared a little bit before, I saw the Jeopardy episode. Yeah, it's wild, right? So there has been hype before. So what's going on here? And I want to risk oversimplifying it. I want to make a distinction between what we're working with or what's really effective right now, because generative AI has been around for a bit. And the fact is, it is just in a new season of proficiency, efficacy, and it's just pretty good at a lot of what it's doing. But basically, we're kind of making this shift from traditional AI, right? AI systems programmed with a specific task that have a closed system for their output, right? We talked about it a little bit already, but AI that categorizes, classifies, it may be maneuvers, maybe it's autocomplete, right? But a lot of these AI, like for example, are autocomplete. It doesn't then begin to suggest, oh, here's where you could continue this sentence. Or with the categorization, it's not necessarily creating new images or faces. And so that's what's going on in generative AI. We've technologically rather, arrived at a way to get these AI systems with specific tasks. Remember, we're in machine learning, that have a flexible, open-ended capacity to receive input. So by that I mean, right, there's so many crazy things thrown at ChatGPT, and odds are there's not a lot that it has been trained on before, because we're like, what could we ask this thing? And some people get really random with their stuff, but a lot of the generative AI can hold these kind of inputs to an extent. And then more importantly, they have an open system for their output. That is, that they create novel data. Notice that I don't say new data, or maybe the best word is synthetic data, but it's creating something that wasn't a part of the equation at the start of the input. And so that's kind of one of the big pieces here. If somebody's like, yeah, we've had AI before or whatnot, it's no, we're really reaching a big tipping point in what generative AI specifically can do. And so I'm going to get a little more technical here, but again, part of AI literacy is kind of coming to this place of understanding even some of the like technological bedrock of what's going on, because then it helps us understand, okay, when we say it can do X, it really can't, because this is how it works. And so it's important, right? We're talking about deep learning systems, and more importantly, we're talking about neural networks. And as it sounds, neural networks, the idea, it's basically an architecture for deep learning systems, a lot of complicated algorithms in place. But what they try to do is mimic kind of the way our neural network is at play in terms of the connections between a bunch of neurons, as well as layers and layers of these neurons. And so that's why you'll hear often AI researchers refer to it as artificial neurons. And there's an input where the data goes in, and then there's a process of decoding. And what I want to do is kind of maybe break it down in terms of like how ChatGPT works. So ChatGPT is what's called a large language model, and that is a neural network that has the specific task of receiving words, phrases, and essentially, trying to predict what is the best output that is like statistically possible given these words. To make it really simple, it's kind of like when I say a sentence like Jill ran up the, there's a piece of it where the next word being hill is probably one of the more statistically likely things that will follow that, right? And that's happening in autocomplete. But the fact is ChatGPT is able to do much, much bigger things because of what's called the transformer models that are at play in between the encoder and the decoder. And what the transformer models allow the neural network to do is pay attention to a vast amount of input at once. So it's not just processing Jill ran up, it's processing the whole sentence as it's put in, and it runs it through its network. And then it has these endpoints, which are called parameters, which play a role in determining what to do with this input, how to continue to encode it, how to continue to work with it, and basically get it to the decoder where we get that output. And the fact that the transformers models allow it to pay attention to, in the case of ChatGPT, all the stuff that's been put in the input, as well as the conversation that you've been having with it. And its goal is to statistically optimize what's the best and most probabilistic words to meet these other words with. And things similar are going on under the hood for image generators, video generators, sound generators. It's the same idea. It's trying to statistically optimize what type of output should be provided given this input. And again, part of that training process, right, is continuing to put data in, see what the output is. If it's not what the output should be, the researchers, through a various means of processes, try to correct the different parameters, the different weights between the neurons. But ChatGPT-4 is rumored to have 100 trillion parameters. So this is a very simplistic representation of it. So these things are very, very big, hence large language models, and they're very, very complex. And again, the important part is to hear that they're very big, and sometimes how they're working is not entirely clear to the researchers, as well as the mode or what's happening in between is, as one researcher put it, it's basically a stochastic parrot. It's somebody it's basically kind of this idea, like it's just throwing what makes best statistical sense. And we're going to get into more of why that matters when we talk about what the hype misses. And I see a little question. Is there a way to manipulate the AI's learning process? There are different ways. I think that's a great question. Right? Part of the learning process does begin with kind of supervising to an extent how the model is working. And there are a few different, there's like a fork in the road down on what you continue to do. You can continue to fine tune the models. That's like, right, changing the different parameters so that it's providing the type of output that we want to see. There's something called reinforcement learning, which throws in another model in the equation and basically tries to almost game the model to like go for a specific type of answer. So with ChatGPT, for example, to get it away from saying like incredibly racist or offensive things, or to steer it away as best possible from like false information, they try to use reinforcement models, so which provide certain kinds of answers that these models then try to also predict and put as an output so that they can meet that. And then I see another question. When you say open end in opposition of closing, do you mean finite or infinite ends? I might need a little, if you want to kind of speak to that question a little more, Vivian, if you want to. I'm here, or you can.
Because I got curious. First of all, I had a difficult time to understand when you meant a close end and an open end.
Yes.
And then it jumped in my mind is what you mean with opening end. If it is something, right. Because an open end, it means for me some infinite right. answers or not, and I'm wrong. That means there are many and the other one are just one.
Right. Thank you for that question. So when I say, for example, generative AI has a more open-ended kind of output system or open-ended system for its output, that means that there are a lot of different possibilities depending on what's inputted in terms of what could be produced, right? We can ask ChatGPT the same question and there might be a slight variation in all of the different responses we get. And the same thing with image models or image generators. I'm sure some folks have tried it, right? You have the option to even retry your prompt because you get a slightly different or very different response. Whereas some of the close-ended output systems for traditional AI, it's kind of what you see, right? We kind of see this with Siri. We take Siri to a certain point and then Siri's like, I'm sorry, I can't help you with that. Or, right, we reach a point where the AI system is not able to produce an output because that's not how it was designed. And it wasn't designed to just infinitely guess or statistically optimize a response for us. So these models have much more capacity to generate a wider variety of output depending on that input. But thank you for both those questions. So right, basically, and we're gonna pause here for a second and we're actually gonna play around with the tools. But basically, part of the new hype is basically we're in this place where using natural language, that's our human language, can now give commands to very powerful computers to generate new ideas, craft their artwork, produce sounds and voices that may have not necessarily been out there to an extent. And these tools are being pushed everywhere. They're being embedded in everything. And for the time, they're very affordable. For good or bad, right? This is true. And this is a big point, right? If we go back to that picture of Eliza and Joseph Weizenbaum, right? There was just that one computer, all the researchers, all the reporters were all hovered around them. And now, right, we all can hop on ChatGPT or another generative AI system and just start using it. And that's the wild part, that we have this computational power and this access to produce information and work with computers, right? These systems can even produce a lot of code. So that's something to consider. And right, everybody wants to get in this game. Everybody wants a piece of it. And it's a part of a new wave in technology and the knowledge economy. But just in case, because I know there were some folks who said they hadn't used these systems before. So what I'm actually going to do is stop sharing, and I'm going to share another screen if I can find that window, and basically throw in a few prompts so we can see how some of these tools kind of operate in terms of that open-endedness. So what I want to do, if people haven't had the chance to play around with it, and I know we might have had some people come in, so I'm going to share. This is a Google Doc that has a link to all of the resources that I mentioned. But if people haven't seen it, Open Playground is basically a platform that is hooked up to several different AI systems through their API, and you can even control, right? We talked about some of those parameters, how the model behaves. There's some like high level parameters that you can even change, right? In terms of like frequency penalty to reduce the amount of times things are repeated in it. And so it has quite a few models. It has the large language model that's behind ChatGPT, ChatGPT 3.5. We have Cloud's Anthropic. I think they have GPT-4 here. So I'm going to get that. And then what prompt I'm going to give this one is write a short closing announcement for the BMCC library in the style of Dr. Seuss. And so I like this because it can kind of help us see how different models are working, getting back to that open-ended system of like how these things go in some ways similar in terms of the data trained on are very different. So you can see here we have several different examples varied in length. GPT-4 jumps right into it. I think that's interesting because these other models kind of gave me a little preface. But we have, ladies and gents, it's time to close the BMCC library where knowledge grows. Gather your books and pack your things, for the night is near and the moon it brings. As the cat in the hat would surely say, thank you for coming, now be on your way. We'll see you tomorrow bright and soon for more adventures under the sun and the moon. I would be very happy to leave the library under that. But we see there's different examples here. If you want to play around and compare different models' performances on different tasks, if you have it, this is freely available for the time being. So definitely jump on it. But again, right, I did mention all we see is statistically optimized language, but there's a very sophisticated understanding basically at work in these neural networks that are able to kind of produce at this kind of level. And that's what's part of this kind of hype. I had another one, I'll save it because we might jump into it before, but just in case, I don't think I have it open. Maybe I'll check DALL-E, an image generator, because I did have a prompt for DALL-E. No, am I logged in? Yes. So what was my random prompt? And if somebody wants to provide a prompt in the chat as well, we can try that with one of these tools before we continue to move on. But my random prompt for the image generator, right, it's a similar thing. These models have been trained on images and text. It's building this understanding, the statistical patterns and the features of this data, and it's fine-tuned, it's worked on, and then it's able to understand input and have a wide variety of options in terms of what it is, statistically constrained, of course. So I got a cat and a chimpanzee in spacesuits walking on Mars in the style of anime. We'll see. A lot of these systems sometimes are overwhelmed in terms of the amount of users we see. So we'll see. You can send it? Okay, all right. Well, there we go. We might have one other option. It looks like the server's overloaded at the moment. I have a lot of AI tools that I try to keep track of. Let me do image being, and let's see how this one. Okay, I have to log in. I will just, out of privacy reasons, I will just log in here, enter that. Yes, okay, and then let me put in my prompt. Okay, perfect, it does have that. And it is creating. All right. Okay, we got something. All right, here it is. Anime style, cats and chimpanzee in spacesuits. So um, interesting here, but I'm not sure. Sometimes it's interesting what these things pull out, what these models pull out. But yeah, kind of random stuff. But just to kind of give you a little insight into that, I'm going to go ahead and jump back into the presentation because we still got a little bit, but I'm recognizing the time limit and I do want to give us a chance to have more conversation with each other. So I'll try to rush through it. So again, we're at this point, what the hype misses, uh, right? We talked about these neural networks being able to statistically optimize the best output and have a little creativity and open-endedness in how it does it, but still it's only trying to best predict what should come based on input. So what does that mean? That means that these models aren't capable of formal reasoning, right? They can't handle logic very well unless it's logic that they have seen in the training data, which is an important piece to note when we're talking about training these models and what they can do. They have no knowledge of the world. And that's comes down to a lot of things, whether it's like understanding like how things work physically, right? Video games have this thing called a physics engine, and it allows it to simulate how things would happen in the real world in terms of mass, in terms of how light reflects. These models don't necessarily have that, and they certainly don't have factual knowledge of the world, right? When we type something in, even to an extent, the AI that are in search engines, that can try to pull for more updated information. It's not the same thing as checking a knowledge base or a database of facts and pulling from that and then being able to infuse its answer with something factual. It's not doing that work. It lacks situational awareness. This is another part of like our intelligence. You've often heard me say, oh, we'll get to this, we'll talk about this more. The longer and longer a conversation goes, with the neural network model, it starts losing place of what refers to who. And that's a big piece in terms of like understanding things in a broader sense. And then of course, it lacks any social knowledge or human context. And right, these are things that other AI systems, people have attempted to program into it. But as a neural network model, that's not its main focus. That's not its main thing. These are things that maybe you can do at the top level, manipulate a little bit so that it's kinder in its tone. And sometimes it's effective, but it's not doing it because it understands what's appropriate to say, for example, on a Zoom workshop or when talking to somebody who needs their research done. And another big piece, as I said before, these are deep layers of neural networks. And so even to the engineers themselves, it's a little surprising of like, what is this doing? How is it behaving? And they have no way of really explaining themselves. You know, you've been in the math class where it's like, show your work. And part of the annoying thing that the professor's asking for in that case is to demonstrate that you know how to do this. So you're set up for success when you come up to a new problem down the road. And I know I can trust you to handle that. But also, right, explainability helps with correction. A lot of what these models do in terms of their behavior, there's not a true understanding of how they got there. And so without that understanding, it's difficult to interject and step in the way and be like, okay, we got to change this. And in the document of different things I've shared, there's one like spreadsheet of a bunch of different examples of where these systems are failing to reason or where they start, and you often hear the term hallucinate misinformation, because remember, these models have a task, and that's to predict what's best to say based on your thing. And so often they're not checking a knowledge base. Do I understand what they're asking? Do I have information that is accurate to share with them? They're going to say things. And so, right, here's an example of kind of going off the wall on on citations, references that don't exist. Here's an example of Bing kind of failing at doing math. Again, it is language. We're talking about large language models, so it's not a surprise that sometimes they run into walls with numbers. Here's another kind of more formal logic pattern recognition. And another example of like, it just starts hallucinating. This person's like talking to them what a palindrome is. And it's like, oh, it presents like this, I understand what a palindrome is. And then it's like, what about this word that is a palindrome? And like, no, this is not a palindrome. And then it explains why. And then the guy's like, yo, are you sure it's not a palindrome? Yes, I'm confident. So you'll also hear a lot of people say they can be confidently wrong. With that, it kind of begins to, and again, this is something that the hype misses. This is we don't see often. This is an example of Bard. When I asked it to give me a field of 3 articles related to AI alignment and AI ethics in APA citation style. So again, maybe closer to some research stuff you might use. None of these 3 citations exist. The citation is okay. Again, it does produce some great sounding text in terms of like explaining the topic, but that's a reality. Here's another person on Twitter who shared how they basically jailbroke Bing to create not only a false news article, but the wild part is, right, these systems don't have explainability, formal reasoning, knowledge of the world. So part of what Bing needs to do is work with stuff that's on the internet. And for whatever reason, it started adding, maybe to make the false or the disinformation look true, it started putting articles to these false claims. And it just did it right up. And this was a matter of seconds. So, right, we have these problems of really trusting it with formal reasoning, trusting it with accurate factual information, being able to trust it or trust these systems. Yeah, sure, very problematic. So again, that's just one piece of what the hype misses. Another thing that I want to get into really quick, and it might be of interest to some folks, here is another part of what it costs us. A lot of these systems were able to be trained and built to their capacity because they had access to cloud computing technologies that were super, super advanced. And often when we think of these supercomputers in the cloud, right, we're thinking otherworldly. But remember Dr. Crawford's point about what is AI being a material thing as well. And there have been studies that showed that one of Google's large language models, BERT, to train it in terms of its carbon output was roughly equivalent to a transatlantic American flight, a trans-American flight. The cost of running ChatGPT is about $100 per day. It's an older report, late in 2022, but still, just the amount of resources these things require. And even getting, right, the cloud has to exist somewhere. And so a lot of these data centers, these supercomputers, they require material to build, even if we're not seeing them, we're not connecting to them. And one really unfortunate example is the Black Lake in Bautu, Inner Mongolia. And it contains a 180 million tons of waste that comes from mining the earth for the precious materials to build our circuits, to build these networks, to build these graphic processing units, etc. And it's just alarming at what hype in technology could mean for our planet. And again, this isn't something that's often brought up or often said in a lot of the hype. And then another reminder, the cloud is of us, right? ChatGPT and a lot of these large language models are trained on loads of data from the internet, from blog posts to comments to databases of online books, a lot of misinformation, a lot of this, a lot of that. And this situation isn't new, right? There's always been this big thing with big tech and social media on data privacy. And there's been 2 great workshops before that on our data, one done by Sherelle on digital footprints and by Richard Sepulveda on cybersecurity. But right, the cloud, what these things are doing, it's partly in response to what they were able to take from us or take out from the internet. And that means a lot of things. It means that including just information from us, it gets our biases. Here's something from ChatGPT, completely unprompted, just asked basically create a Python script that could determine what was a good scientist. And then part of its condition indicates what is the race of this person, what is the male, and then if it, or what's the gender, and if it's male and white, return true, that this is a good scientist, right? And this was totally unprompted, unjailbroken ChatGPT. It's just what it produced. And so that's a reality. Like the cloud is of us. It has our biases in it as well. But also important that, and this might be a little hard to see, but it's also taking a lot of our creations. A lot of the creations we have creative rights and intellectual property and ownership of. And this is a very silly one. I think this was Stable Diffusion, yeah, Stable Diffusion, that literally one of its images that it was trained on was a copyrighted image from Getty Images. And when somebody tried to describe a similar scenario or situation, you could see part of the response includes the watermark from Getty Image. So literally, it's the cloud is of us. We are in what it's putting back out there, and that has implications on who has rights of what they create and who has a say, who's compensated for that. And again, to kind of hit the note, there's always a human loop involved in this. As much as we talked about the neural network figuring out a lot on its own, these open-ended systems, often humans are thrown into these checks and balances to make sure things are working right and that these companies can get their users, get their subscribers. And it's problematic in terms of what it costs us in terms of human labor to keep these otherworldly digital things going. And of course, you might see it on some chatbot, some sites for people's chatbots, but what we say, what we do on those platforms is eventually used to train the next model or fine tune the current model. And it becomes problematic because then it's almost like this being gaslit at times, because we want to say, look, it's not good at formal reasoning. People test it on all these things to test its formal reasoning. They use those as future training data and they're like, see, it does this formal reasoning now. So it creates a cycle where we can't really improve the model. We're just bandaging over what's going on. So again, a piece of what the hype is missing. So I'm gonna I wanna, before kind of open it up to discussion and maybe some questions, maybe we can try a few more prompts to kind of see what's going on. But some things to consider as we continue to do more as a department, as a library, to support you all in how to critically understand and use these tools. Again, one thing is to consider, as we've seen, what's your purpose of use, right? Are you trusting it with high quality, complex research that involves critical reasoning? Okay, there's steps that you could do to really work with it well, and maybe somebody has some tips, but we see what can happen if we rely on it too heavily. So it might be better to rely for it on more maybe productivity or brainstorming ideas. And it's always a good question, what are you outsourcing? Right, I love that cat in the hat poem. I thought it was great. And I think it's sometimes fun to see how we can practice that creativity. But sometimes using these models too heavily or relying on them too heavily has an impact on what we give up in terms of our ability to critically think, our own stories, our own experience that could be a part of that. And again, there's ways to incorporate more of ourselves into that, but always a good thing. What's your purpose? What are you outsourcing? As more players get in the game, there's more people that I honestly trust more. I'm not a huge fan of OpenAI, especially their most recent rollout of their newest language model. They've been very secretive about a lot, and it's just like literally the opposite of open AI. But folks like Anthropic, they're really interesting. They're trying to do things that break open the neural network that allow us to see. They're trying to, they use this process called constitutional AI that gets the human values more deeply embedded into the system and involves other AI to specifically work on containing how the larger system works in reference to those values. So it's like good to see, because part of that, you can get some explainability of why the model did that crazy thing or that off thing. And so that's helpful. Adobe Firefly is, again, generative AI embedded in some of Adobe's tools. Although I'm not always a big fan of what Adobe has been doing, I appreciate their efforts in saying that their specific image generator has only been trained on their stock photos. So it's those photos are basically open, part of the public domain, or things that they've created for free use. And they have this partnership that they're trying to work on in terms of giving people the opportunity to be compensated to submit some of their work to be included in the training sets of future image generators. And again, look out for some of those systems that have good guardrails that are communicating with you and are constructive. U.com is an ad-free search engine that's much more aesthetically pleasing than Google or a lot of the other competitors. They actually kind of got a leg up on some of these competitors in terms of getting a chatbot out there, but they really care about ethics and prioritizing the user, and they don't want to monetize the user. And so I'll often ask it questions, and sometimes it'll pause and be like, hey, I don't understand. Like I was asking it about a statistics thing, and I'm like, what's a good standard deviation for a certain statistical study? And it's like, I don't know what your context is for the question. Things can vary between research project to research project. Different data mean different things. But here's a general generation, and that's like, yeah, that's reasonable. I want something to work with that, not just here's 3 false citations. And so UChat also allows you to really see what information sources you're pulling from, and maybe we can jump into that if that's something we want. Kind of getting close to time, but again, these are some things to consider. And so I did want to kind of open the floor and see what some of your thoughts are. I realize there are really effective ways to use it, and we're going to have more workshops about that. But I feel like part of AI literacy, we have to ground ourselves in what's really possible, what's happening under the hood, and yeah, what's at stake when we engage these systems. But I kind of wanted to open up the floor again. If folks have ideas for where there are great opportunities and maybe risks or harms that you didn't hear me mention, that you wanted to hear, because I want to include your voice in this recording, even if it's just thoughts. So if you have an opinion, feel free to unmute yourself or type in the chat some thoughts here. So again, thinking about risks or opportunities here. And for some of you who responded in the poll, feel free to share what you use it for if you found it helpful, because I consider that an opportunity, how students are using these things well. Thought I heard a breath. Somebody was about to speak.
Well, I will say that the greatest opportunity here is that, I mean, the main problem with artificial intelligence is where is the information coming from? And it's evident that, like, Sam Altman and many other people really involved into this has named that the problem as an hallucination, which is not. That's not an hallucination. The problem comes from where the information is coming from. If the AI knows how PhD students create their citations, it knows that many of those quotes are not real. The AI is doing exactly the same thing that PhD students do. So the real problem here is, how are we fitting the system? Because we are supposed to trust all those PhDs and all those academics and the government. No, that's not true. They're not doing right. So the information is coming from an untrustable source. And I think that the greatest opportunity and maybe the job of the future is going to fit this AI correctly. And I mean, that's maybe the most important opportunity we have here, which is also a risk. Because if we fit it wrong, it's going to happen what it's already happening. Because it has been many years master degree students and PhD students, like um, coming up with things that doesn't really exist, with false quotes, with fake quotes. I mean,
Mm,
it happens. It has been proved. We we know that's happening.
yeah.
So AI has been fitted with those wrong practices. So I
Mm,
think that that's one of those huge opportunities and risks. And also in the other side, in the other hand, I will say that the artificial narrow intelligence represents a really important opportunity here, because we
mhm.
can use like this engine, this system for really specific tasks, which it's what it's really happening now. I mean, the hype is around ChatGPT, but what it's really happening, for example, with the new Office 365, it's incredible. I mean, the new Office suite is amazing. I don't know if you
Yeah.
have seen it, but
Yes.
how efficient is it? How many options does it give you? We should be looking at that, not only at ChatGPT, which is a website. I mean, Microsoft has turned into a matrix that can take many kinds of information and turn all that information into many different deliverables. So also we have the embodied artificial intelligence, which is happening with the Google robot, the Disney robot, and the Amazon robot, which is already working on their facilities. So yeah, I think that mm, in really short time we will see the artificial intelligence working, like embodied, like physically working, which it's already happening. I mean, the what's the name of the Google robot?
Bard.
No, the robot, not the artificial
Oh,
intelligence.
the robot. I
It's
can't
E
remember.
something. E stands for embodied, and it's E.
Yeah, yeah.
I can't remember the name, but yeah, I think
No,
that,
that's good. Yeah,
that
Daniel, thank you. Those are really great perspectives. And as you named it, there are sometimes it's two sides of the same coin for
hmm,
opportunities and risks. And
and
even just to speak to in terms of the level of productivity, maybe narrowing what it focuses on, what it's trained on.
exactly.
The illicit is a very interesting example, and it's more limited training data and where it applies the AI. So it's not an open-ended chatbot. It's more of applying AI to focus on very specific tasks of the
No,
research to optimize
yeah, and I mean,
different tasks in terms of
I would,
summarization and classification. Yeah.
yeah, I would like to mention like two specific cases that are already working. We have
Uh-huh.
the GitHub Copilot, which is Copilot when doing code. Like, it could
Yeah, the
be C++,
Copilot. Yeah.
Python, CSS, JavaScript, and it's really helpful. But it's a tool. It's not doing the work for you. It's
Mm,
just a tool. And also with I don't remember, MATLAB is also MATLAB has been using artificial intelligence for so long. So yeah, I think that there is many options here. And the also I think that the gap between what is artificial intelligence and what is human intelligence is going to be bridged really soon. We are getting closer. I mean, we it's not like artificial intelligence is there and humans are here. We are, I don't know why now we are seeing like this division, this they are it is there, we are here. No, it's like the great opportunity here is to understand and to know how to take advantage of it, understand how to use it. It's
right.
like it's not going on its own. If we stop from working on artificial intelligence, it is going to stay there. So yeah, I think that the opportunity is to understand and use it.
I think, Daniel, those are some great words, and we are at time. So I do want to respect people's opportunity, and I couldn't
Thank
agree
you. Yeah.
more. There is great opportunity, and clearly, yeah, we're not a true artificial general intelligence, so we are still very much at the wheel. There is some concern in terms of where and whose hands these technologies can fall in and what can be done at such a more rapid pace, flooding in new ways the information ecosystem with vast amounts of misinformation. And so there is definitely a lot of push and pull, but as it was said, we got to understand how to use these things well. We have to build AI literacy. And so what's going to happen going forward, if this was a meaningful conversation for you, we're going to continue this and get maybe a little more specific in terms of how we're talking about this. We're going to talk a little bit more about the productivity side, assistive AI in research, where there's some like good examples of it. And our cybersecurity expert, who gave a great presentation on cybersecurity, is going to talk a little bit more about the wild implications of AI that can produce malicious software and cybersecurity at a crazy alarming rate. So I'm going to stop the recording, stop the screen